Today I'll be showing you how to complete the square. If you remember, we can square a simple expression like x plus a squared and get quadratic x squared plus 2ax plus a squared. Expand that the long way if you want, but if you know the shortcut, you should be able to do this. So for instance, if we had x plus 3 squared, we'd end up with x squared plus 6x plus 9. Now, what complete the square means is to find this number so we get a square expression which can be turned back into this. So as an example, if I give you x squared plus 8x and I ask you what the last term is, if you could answer that, that'd be completing the square. Now to do this, we should look at this part over here. If you halve the middle term, so the 2a, you'll get the a, and once you find the a, you can turn that into an a squared. So for this example over here, half of 6 is 3, so a would equal 3, and a squared would equal 9, which is exactly what we got. So for the example I just gave you here, a would equal 4, which is half of 8, so a squared will equal 16. In other words, this expression would then equal x plus RA, so 4 squared. So remember, the a is the term inside the bracket that's squared. It's half the middle term, and the a squared is our constant term. So let's try and complete the square with two more examples. First one, say I give you x squared minus 4x, and I ask you what the last term is. Well, in this case, a would be half of minus 4, which is minus 2. So our a squared would be negative 2 squared, which is positive 4. Notice that our last term is always going to be positive because squares are always positive. So our last term would be 4, and we can turn that into x minus 2 squared. We can expand that to check it. One last example before we move on. X squared plus 3x. Now, notice that our middle term is an odd number, but that's not going to stop us here. A would be half of 3, which is 1.5. And if we square 1.5, okay, 1.5 is 3 halves, so square root would be 9 quarters, so it's 2.25. So our constant term is 2.25, and we can turn it into x plus 1.5 squared. Now remember, you can also check this. So if we've got any monic, and by monic I mean the x squared starts with no number or 1, we can now complete the square. So, why is completing the square useful? Well, it's useful because it is another way of solving quadratic equations. Say, for instance, I have the quadratic equation x squared plus 6x plus 8 equals 0. And I want to solve this. Now, we can factorize this, and we can use the quadratic equation, but completing the square gives us a third way of solving this. So now, if we just have a look at our first two terms, we have to complete the square on this. Our a would be half of 6, which is 3. So a squared is 9. So what we want is x squared plus 6x plus 9. Now, in order to turn this equation into this one, we obviously have to add 1 to both sides. Now we've completed the square. This side, the left-hand side, turns into x plus 3 squared, and our right-hand side turns into, well, the square root of 1 is just 1, so it's 1 squared. Which means we have x plus 3 equals, and here's the tricky part, positive or negative 1. Because we take the square root of both sides, but we can't neglect the positive or negative. Which means x is either minus 3 plus 1 or minus 3 minus 1. Or in other words, it is either minus 2 or minus 4. So let's just double check this. If we had factorized this, we would get x plus 2 times x plus 4 equals 0. You can check this. Which means that x plus 2 equals 0, or x plus 4 equals 0, which means x equals minus 2 or minus 4. Fantastic. So let's see where completing the square really shines in solving problems. Say we get x squared plus 3x plus 1 equals 0. And we know we can't factorize this. There's no two numbers that multiply to give 1 and add to give 3. And we could use the quadratic equation here, but as we know, the quadratic equation is longer, more complicated, and more open for errors. Let's see if we can't complete the square on this one. Now, our a is going to be half of 3, which is 1 1/2 or 3 halves, which means our a squared is going to be 9 quarters. But notice that in our original question we have 1, or in other words, 4 quarters. I'll just write it over. So in order to turn the left-hand side into a square, in other words, to turn the constant term to 9 over 4, we have to add 5 over 4 to both sides. So now we get 9 over 4 as a constant term, but we have to add 5 over 4 to the right-hand side. Now our left-hand side is a square, so we can turn that into x plus our a, so that's 3 over 2 squared. Now our right-hand term, well, the square root of 4 is 2, so that's easy. We can have a 2 on the bottom. 5 isn't a square, but we can just leave that as square root of 5. Now we can just take the square root of both sides, which means we have x plus 3 over 2 equals positive or negative square root of 5 over 2, which means x is going to be equal to minus 3 plus root 5 over 2, or minus 3 minus root 5 over 2. Now if we'd use the quadratic equation, we'd also get this result. However, notice that this takes a few less steps and is less open for error. So let's just solve one more problem and then we'll get the hang of it. Say we have x squared minus 2x minus 1 is equal to 0. And we can quickly tell that we can't factorize this. Well, a is half the middle term, so a is negative 1. So a squared is going to be positive 1. So in order to turn this constant term into positive 1, we have to add 2 to both sides. So we get x squared minus 2x plus 1, and we add the 2 to the right hand side to get 2. Okay, should be able to see this. Now the left hand side is going to be x plus a, so that's minus 1 squared. And our right hand side, well, square root of 2 is just square root of 2 squared. Now we can take the square root of both sides, so x minus 1 equals the square root of 2, plus or minus, don't forget that. It's very important that you remember this. Which means x is either positive 1 plus square root of 2 or positive 1 minus square root of 2. And we've just solved this question quicker than if we'd used the quadratic equation and with less chance of error. And that's it.